All right, 5.5, multiple angle and product to sum formulas. All about these formulas. I'm going to show you where these formulas come from in class, but right now we're just going to use those formulas in evaluating. So we have sine 2u. Notice we're going to have sine 2x here. We have 2 cosine x, which is already known. Let's go ahead and use this formula and see if we can simplify this or turn it into a factored form. So we get 2 cosine x, and it's sine 2x. Sine 2x is 2 sine x cosine x. Notice these have different arguments, which means we can't factor or do anything else with it until we get it to be the same argument. Notice now it's all x, which means we can factor. Notice there's a cosine x and there's a 2 in both terms. So it's 2 cosine x, 1 plus sine x. And this is equal to 0. Well, if you have two factors equal to 0, you can just split them apart and set them equal to 0. Cosine x is equal to 0 on the unit circle at pi over 2 and 3 pi over 2 and everything around. So this is pi over 2 plus n pi, because it's a half circle away. Sine x is equal to negative 1/2. Sine is the y value, negative 1, only there. So that's negative, 3 pi over 2 plus 2n pi. Something to notice here, though, is that all of these angles are contained in that right there. So this is the cleaner answer, because every 3 pi over 2 angle and coterminal angle with it is part of this. So you just need to do the pi over 2 plus n pi. All right, double angle formula. We have y equals 4 cosine x minus 2. Use the double angle formula to rewrite. Notice the cosine squared is, we have the cosine squared right here. I went ahead and showed what's in the book. Notice we have our equation, and if you factor out the 2, you get this, and you get one of the double angle formulas, which is cosine 2x. And that's it. You're looking for where this crosses the x-axis. That's here and here and so forth. So just using those formulas once again. All right, let's go to the bottom one. So we're going to use this to use the cosine 5 pi over 3 to find sine 2 theta, cosine 2 theta, and tan 2 theta given these values. So let's go ahead and write out our formulas for sine 2 theta, for cosine 2 theta, and for tan 2 theta. All right, so we have sine 2 theta, 2 sine theta, cosine theta. Cosine 2 theta is 2 cosine squared theta minus 1. We do have a formula for tan 2 theta, but if you have the sine and the cosine, which you've already found, then we can just divide them. Now, we have cosine given of that angle, and we need to find the sine that goes with that angle. Notice it tells us what quadrant we're in, which is quadrant 4, and this value is 5. Or, 5. That's terrible. All right, so we have our x value of 5, our y value of negative 12, and our radius as 13. So our sine value is the opposite, which is negative 12 over 13. So sine theta is equal to negative 12 over 13. And our cosine value is given, and we just simply plug all these values in. So sine theta is equal to negative 12 over 13. Cosine theta is equal to this, and you can plug it in here too. And once you evaluate both of those, you plug it in here and here. And that's where we get these different values. Noticing we're just simplifying the fractions. Deriving a triple angle formula. Like, let's say we have sine 3x. Well, notice that's 2x plus x. So we have to apply our sum formula, which is psycho cosi, same sign. So we have sine 2x cosine x, same sign. So cosi is cosine 2x sine x. We got these two x's in here, which is double angle formulas. Remember that sine of 2x is 2 sine x cosine x. We still have this other cosine x. And then cosine 2x is a variety of things. We have a variety of options with it, but I'm going to choose to do the 1 minus 2 sine squared x. In fact, I'm going to go back to my formulas to make sure that I wrote it down correctly, because it's something you need to be doing too. And that's this one right here. All right, now it just comes down to simplifying it, creating a new formula, remembering that we could have done several things for the cosine 2x. So this is 2 sine cosine squared x, and then we have the plus sine x minus 2 sine cubed x. And it just comes down to simplifying this, noticing that all three of these have sine, but I would consider this pretty well simplified. Except I suppose we could change this cosine squared x into sine squared x by using the Pythagorean identity, noting that cosine squared x is equal to 1 minus sine squared x. But that's still being multiplied by 2 sine x, and I'm getting this from this one right here. There's an x right there. And we still have the plus sine x minus 2 sine cubed x. So we have the 2 sine x. I'm going to distribute the 2 sine x into those. Sine cubed x plus sine x minus 2 sine x. All right, we have the minus 2 sine cubed x minus 2 sine cubed x, which is minus 4 sine cubed x. And then 2 sine x plus sine x is 3 sine x. And I believe that's it. The next example I'm just going to talk through, noticing that we have sine to the 4, or sine x to the 4, and it's the same thing as saying sine squared x squared as well. And we've got our power reducing formulas. Talk about where these come from next class. So we got sine squared some value. Noticing that, remembering that sine squared is equal to 1 minus cosine squared, but if we're going to reduce this power, this is our new formula. So then we can plug it in here, and this is just a bunch of algebra stuff. Please look it over to make sure you're familiar with it. All right, half angle formulas are crazy. They come from a crazy world as well. So we can evaluate, with these formulas, we can evaluate precisely other angles like sine 105, keeping in mind that sine 105 is the same thing as 210 divided by 2, remembering that 210 is a unit circle angle. So our formula for sine of the angle divided by 2 is plus or minus the square root of 1 minus cosine of that angle, and that angle in this case is 210 divided by 2. Now it just comes down to plugging, chugging, and simplifying. Cosine 210. 210 is the 30-degree angle past 180, and cosine in this case is the long one, which is negative root 3 over 2. We still have the 1 minus it, and it's all over 2. Square root all plus or minus. All right, so now we just need to simplify. We get 1 plus square root of 3 over 2, all over 2, square root all plus or minus. This is, I'm going to do the butterfly, putting this over 1, so this becomes 2 root 3 over 2, but all of this is being divided by 2. Then 2 plus root 3 over 2 divided by 2 is the same thing as multiplying by half. I would not normally write this step, but I'm doing it for you guys who need to see it. And that's as far as we can go because this has a radical, excuse me, this root 4 can be square rooted, so it's 2. And that is as far as you can go. But I got one last statement to make. Remember, this is the same thing as sine 105. 105 is in the second quadrant, and sine is positive. Therefore, only the positive answer is taken. Excuse me, not the negatives. So it's just the positive value. That's it for this video.